Hi everyone. Thank you for joining our call today. We're thrilled to have it today, and we already have 24 people. Wow. Without further ado, Maxim, go ahead, start.
Hi everybody, and yes, thank you for joining. Today we will continue the demo of RGB. We already been doing that for the 3 previous calls, explaining different parts of the system. And this week we released the final components of RGB. So today I will be demonstrating the assets transfer, as also as doing small recap of everything else that is out there. I'd like to point out that the thing that we will be showing today will be still quite low level, because we will be basically demonstrating how the system operates from the point of view how it would be seen by the developers, by the wallet developers, by people who will integrate RGB, or by power users. More user experience, better user experience will come from the products which will be developed by these developers on top of RGB. So these products will come from different vendors. We are also working on some of them. So for sure, for end users, these things would be much more simple and much more user-friendly with a graphical user interface. So what I'm trying to do today is to explain what is underneath that. And in the future calls, first of all, everybody who develops products on RGB are invited to present them and to show how they can be used. And we also will be doing more presentations demonstrating more high-level stuff. So that's the journey we have been in since the 9th of February, when we released the consensus level of RGB, and since that time we continue to releasing layers of application stack on top of it, with the final thing being released yesterday, which is the command line tool that allows to use RGB. And with this new version 0.10, it's not this version doesn't only brings the whole power of smart contracting with a lot of programmability features, but it also simplifies how you interact with RGB. Before, you had to install the RGB node, run it as a service, then talk to it through the command line tool or through the RPC interface. Today, with the new version, it is still possible, and if you'd like to run RGB on the server, the RGB node would be the way to go. But we did also a command line tool which doesn't require any server. It's just a simple instruction, RGB, that allows you to do everything that is related to RGB. And this simplified command line stories and demos quite a lot. So I hope you will be able to see that today through the demo. So the RGB command is deliberately designed pretty much after Git command. The Git command works with the repositories locally on the machine with all this client-side data. Git has nothing to do with the blockchain, and when you're using Git, you are not thinking about blockchain at all. So we were trying to stick to the same concept with this RGB command, such that the use of blockchain is completely hidden from the end user. He just does things with locally stored data. And the only time when blockchain is needed is when RGB talks to Electrum server. And we provide a default Electrum server, which is a Blockstream server. But of course, you can always configure it with using a custom Electrum server if you'd like to. How you can install RGB? Well, you can install it with this cargo install RGB contracts command. You need to add flags all features. Of course, you need a Rust for that. So if you don't have cargo locally, you need to go to the Rust repository and install it. So let me show you how it looks in the console. Olga, I'm now switching to the console. Do you see it?
Yeah, switched.
Okay, so at this moment, this command cargo install RGB contracts in this way it can't be run because we are still waiting for the release of latest Electrum client from BTK team. So for today, you need to do that from inside the repository. And I think once the Electrum client will be released in a few days from now, you can also do that without cloning the repository itself. So you clone the repository with the common git clone giving the path of the repository, which is on GitHub, RGB working group, RGB. And that's it. It will clone it locally.
Sorry, excuse me. Can you, I actually only see like the presentation screen. Are you actually making a demo?
You need to switch because we can't switch for you. There are two of me with the two different screens. So you have to
I'm sorry. Okay, thank you very much. Okay. Bye.
Do you see it?
Yes, I see it now. Thank you.
Cool. So you clone the Git. It wouldn't work right now because I'm already having the local clone. So I'm just changing to it. And you may see that it's the repository with everything inside. Now we are building it and installing it locally to have the RGB command available on the system. We do that with the cargo install from the current directory and all features flag, which is required to produce the command line tool. So that was quite fast because I already had it installed, but on your machine it would probably take a little bit longer. But still, anyway, here we have the tool available. So RGB, you can run RGB with a simple command. And you see the list of the commands that RGB supports. It actually provides everything, starting with the contracts and issuing new contracts, doing transfers, all RGB operations. Additionally to RGB operations, it also provides a way how you can link RGB to a specific wallet. So for the first time, RGB now ships with a built-in read-only wallet that allows you to see which part of the contract state belongs to one or other wallet, and also analyze to examine the UTXO set of the wallet. There is also a couple of commands which you may find useful, like inspect or dump. These commands allow you to look into RGB specific files and see the internal structure, or if there is something going wrong and you are reporting an issue, you may like to run a dump command to export all client-side validated data and upload them for us for an examination. So that's the tool that does it all. The other thing I would like to point out that whenever you need to change the Electrum server, you can do that using the Electrum flag. Also, you can configure the network you are working on. Today, I will be doing demo on the testnet, but you can change it with an end-chain flag. Also, you may have a different stashes on your local machine. The stash is the thing which stores all the client-side data, and you can configure your stash with this D parameter. By default, all client-side data are stored in the .rgb directory of your local subdirectory, which have a of your home path, which has a subdirectories for each network, and there are two files, which is a stock.det and wallets and list of wallets. So this file contains all client-side validated data, and this file contains all the wallet information. Again, if you need to debug something, we will probably ask you to send us these two files such that we can look into your stash. These are also the files that you might need to back up if you are working with, actually you need to back up the whole content of this RGB directory. Today I will be using two setups. So there is another directory which I created, which is RGB alt, which contains different stash. So I will be sending from one user to another users using these two different stashes on the same machine, which also simplifies the thing. And the first thing I would like to demonstrate is running RGB contracts command which reveals the list of the contracts which exist locally. And I can also check the state of these contracts with running this command, specifying the interface I'm using, which reports me the balance of I have locally. I will get back to this in more details in a moment. For now, I would like to switch back to the slides because I need to explain now what contract is, what interface is. I already did these explanations before, but for all those who joined us for the first time, I would like to say a few words about them and how actually you can get contracts and how you can get all these interfaces into your system. So back to the slides. Please switch your screens.
Done.
Okay. So the contract is quite a familiar concept. I think most of you know what the smart contract is. So it's a piece of information that can be automatically executed depending on certain conditions. And the contracts in RGB are the same contracts as in any smart contracting system. So they have their own state, you do operations over the contract, with the only difference that here the contract is not stored on blockchain. It is stored on the client side. And the only thing that is going to blockchain are the commitments to the contract state, Merkleized contract state, basically. So the contracts, I think it's quite clear. We wouldn't spend more time here. The problem that contract may exhibit very different things. They may be token contracts, NFT, or DAOs, or identities, or many other things. And when you using certain software to interface and work with the contracts, there is no way how the software can know what the contract can do. And that's kind of problem. That's why we, in this version, so before, RGB was solving this problem by hard coding the specific contract types into the client itself. So if somebody would create a new type of contract, all wallets have to update, and to start supporting this contract, the wallet developers has to write new code or publish a new version of the application. Users has to install this version of the application. So that's the way it was working before. With the new release, this has changed. We introduced the concept of interfaces, which explains to the software how the contract can be interacted, what state it does, exposes what is semantical meaning of that state, and what contracts, what operations can be performed with the contract, what data types are there, and so on and so forth. So that's what interface is. And now, wallet or any other software see the contracts through the interfaces. So in my demo, I will be showing you that when I'm requesting a state of the contract, I'm always specifying interface. Or when an invoice is created, it is also an interface information is a part of the invoice, such that user may know how to construct the payment matching the invoice. So that's the introduction to the interfaces. Now, because of many components RGB contract consisting of, I would like also to explain the roles. What I will be showing in the demonstration will be related to multiple roles, like something will be done by developers, the other operations will be done by issuers, other operations will be specific to users of RGB contracts. And as I said, this RGB command line tool, it covers all of these operations. So I will try to, before doing the actual demo, I will try to distinguish that roles so you wouldn't be scared that you need to do everything of that to use RGB. Actually, as a user, you will probably do just few things, and most of the things I will be showing today wouldn't be related to you. But I still have to show that to explain to others, for instance, developers who are present, how they can create new contracts or even interfaces. So there is three main user roles in RGB. And these roles are developers, issuers, and contract users or contract owners or contract state owners. You can use them, name them differently. I will use just simple users. So developers, it's quite clear. They develop the stuff. Issuers is the role which is non-typical for the blockchain-based smart contracts. And in RGB, we deliberately distinguished issuers from developers. So issuers are those parties who issue smart contracts. For instance, it could be a company that issues its own corporate shares, or it could be a company that issues a stable coin. And this company who produces the smart contract, it doesn't need to know how to program at all. Because with this distinction between developer and issuer role, the issuer will use the code created by developers, this code base called schema, and then issue a contract basing on that schema. And the developer can develop certain schema that does some things, implements a couple of interfaces for that schema, and publish it or sell it, and the issuers can buy a pre-existing schema and issue a contract basing on that schema. So in these terms, you can think of schema as a template for the contract.
You were saying that schema is basically a template that simplifies the life of wallet developers and contributors.
Yeah, of not wallet developers and contributors, a life of each contract issuer.
And contract issuers.
And they can just use existing schema created by others, are not required to learn how to program RGB contracts. Developers is not a single class. There is different types of developers, and they would require different skills, again, which is quite distinct from the other smart contracting system. There are schema developers who will be doing schema. There are interface developers who will be doing interfaces, and doing interfaces is harder than doing the schema. And there are some, let's say, UI devs. By UI, I mean that the devs who implement specific interfaces for existing schema. This implementation can be done by schema developers, but it could be also that a separate class of developers would exist, which will do an implementation of interfaces for the schematic. I will be showing this process in a couple of slides. So, the interface developers. There probably would be very few interface developers. I expect that with the launch of RGB, we will be publishing 5 basic interfaces, and I expect that there would be maybe less than a dozen of other interfaces existing in the whole world. So probably the number of interface developers would be really small. And they write the interfaces and instructions on how to operate with the contracts, high-level abstract instructions. And actually, I will probably switch to demonstrate how an interface may look like and how it can be written, such that it will be easier to follow the line of thought without moving back and forth between interfaces and the other parts of the system. So I'm stopping on this screen, and I'm back to the screen sharing. Okay, do you see another part?
Mm-hmm.
So here I'm opened a repository which called RGB-SC, RGB Smart Contracts. It contains some sample code. So if you clone the RGB workgroup RGB-SC in the directory examples, you will see this RGB20 simplest Rust file. And this is how you write the interface in the Rust. So moving to the interface part. One second. You have the interface as a part, RGB20 interface, which covers all fungible assets as a part of RGB standard library. So you're actually not required to write it ever. It is shipped with the standard library. But if you'd like to modify it or create your own interfaces in the future, you may look into this function called RGB20. And you do that by just declaring the data structure called interface, iFace for the shortened version, where you specify the version number. Now we support just one, the name of the interface, and information about which type of global state the contract operates, which types of assignments it creates. Assignments is the state that is assigned to certain single-use seals, meaning that this state is owned by a certain party. And then you structure the operations, genesis operation of the contract, and specific state transitions with their name. So here, I declare that in the global state, any RGB smart contract should have a data structure called nominal, and this nominal should come from the types of contract nominal. If you look into the standard types I'm using here, this variable, the standard types builds this nominal structure. You see this process, it actually compiles the real raw structure of nominal type, which provides the contract ticker, contract name, contract details, and precision of the contract, which can be of different decimal precision. So this nominal structure covers all this information, and then you compile, once again, you compile this structure into type system. So you basically have the structure that builds the type library out of Rust data types, and later you are using this structure from the from your code when you declare the schema. Here it is. And then you just reference the name of the structure and assign it to a specific type of the state. Sorry, I'm not in the part here. You say that the global state of type nominal is linked to this Rust data type. Then you declare the assignments, which is the own state. And in this case, we have just one type of assignment, which is assets, as assets owned by some party. And you specify these assets are always an amount, so meaning that it is a fungible number that can be added and subtracted with other fungible numbers. Finally, in Genesis, you need to specify the amount of assets you create. You can create multiple assignments with the assets, and you can provide nominal and contract text only once. And there is one type of state transition, which is transfer of the ownership. You don't have any global state in this state transition, but you need to spend certain amount of assets. You can spend actually multiple outputs. Here it's specified. And you allocate these assets to a new outputs. Again, it can be multiple outputs of this asset type. And that's it. That's the interface of the contract. You also define things like a default assignment, which should be assigned as an asset type, and default operation, which should be transferred. These default operations are used in the command line when you do a transfer and do not specify a concrete operation. It takes the default operation from the interface. So that's how you declare the interface. And let me go back to the slides. Okay, do you see the screen?
Mm-hmm. Yes.
Next, there is a schema developer who develops the schema, which is the contract business logic. And then the same guy may provide an implementations for existing interfaces for that schema. The schema may implement multiple interfaces. For instance, you may have a contract that exposes both non-fungible and fungible token, or multiple tokens, or a token and a digital identity, or all together plus some sort of DAO interface, and so on and so forth. So each of these interfaces is a separate interfaces, and you do them as a multiple interface implementation for a specific schema. There could be also random guys, those I called UI developers on the previous slides, which may implement new interfaces for existing schemas, and they don't necessarily the authors of this schema or the authors of these interfaces. Meaning that, for instance, anyone may see that there is a way how you can access multiple existing smart contracts by creating some new type of interface and then implementing this interface to existing smart contracts. And the users will be able to interact with the smart contracts in a new way without modification of the smart contracts themselves. These interfaces and interface implementations then can be published and distributed across users as a binary files or as a text files. So you, for instance, can download and install a new interface for your existing smart contracts from the web right into your wallet, and you are not required to update the wallet itself. Of course, this opens a way how people can do bad things with that. That's why all interfaces and all interface implementations are signed and by the developers, and it will be up to the user and up to the specific wallet policy which signatures they do accept. They may rely only to accept interface implementations which are coming only from the schema developer, or they may have a less strict policy and accept the interface implementations from some trusted developers or audited developers. Or if you are reckless, you can accept interfaces by any party. So let me show how the actual schema interface implementation is looking like. Again, I will be switching back to the demo screen.
By the way, I think the problem with your screen just shutting down from time to time is happening due to you not moving the mouse, and the application kind of goes into hibernation or something like that. I think that.
Okay, I will try to move the mouse.
Please do. Thanks.
Okay. So the schema declaration. Here I create a schema for the smart contract I will be using today. It looks pretty much like interface. It's just a different set of data types. So instead of using the names for the global data types, because this schema will be implementing just a single interface, I don't need to add more things to it, but I can actually add more things if needed. Anyway, instead of using the names as I did in the RGB20 interface, for the schema, I have to use the constants. These constants, I define the constants. These are arbitrary integers, which define a type of the state or a type of the operation, and I declare how they actually behave. Relative to the interface, there are several new things here, which is, for instance, a metadata for the operation. These metadata are used during the validation. They are not part of the contract state. They're just a local information. You may think of metadata as something similar to the witness structure in Bitcoin transaction, which provides arbitrary additional input data for the transaction. There are also an important part, which is a script. And this, here you have the script written with the Alluvium, which is the virtual machine for the RGB. And you specify an entry point for validation of certain type of state. You can also validate specific state transitions and other forms of operations. And you specify the entry point, which goes from the library. I'm declaring above. So I'm writing this very small library, which just makes a sum of inputs comparing to the sum of outputs. They must match. This is a single operation using Anderson commitment. And the whole validation script consists of just this single operation, linking it to the asset type which we are checking. And then we assemble this code into the library and stick the library here. As well, we compile the type library once again for the schema. And now, when we're linking the schema to the interface, we are doing that with this interface implementation. We're taking the schema, we are taking the interface. We create this implementation of the interface for the schema. And we link these constants to these types we declared in the interface. If they will be of different type, the compilation will fail and the implementation wouldn't work. But basically what it tells us that the wallet, when it looks into the smart contract, the wallet will know that the state with this ID 0 would have the structured data of the nominal type, and it will be able to parse this binary data into a structure which can be present in the user interface. So that's the implementation. And when we compile these things, we just here, I'm taking the schema, I'm bundling it, and I'm saving it to the file. I'm doing the same for the interface implementation. And the rest of the code is the issuance of the contract in Rust. I was showing it before, and today I will be showing how to do that from the command line. So I wouldn't touch this part ever again, except that this is how I generate the binary schema and binary implementation. And if I run this code, you will see that this was the schema produced. This is a text encoding of the schema. Each file in RGB has two encodings, the binary, when you save it to a file, or base64 based ASCII encoding that is available if you'd like to send the data through the messenger or in email or any other text-based channel. So this is the schema in ASCII representation, including all its type system and everything inside. So you can copy it and send it somewhere or to somebody. And this is the interface implementation. This is interface implementation, which you also can save and share. They are also saved to the files. Guys, you're writing that you have connectivity errors again?
Well, on my side, everything is fine. I think, did you just switch off the video?
Yes, I just switched off the video because I will be changing.
Yeah,
I actually have been getting bandwidth errors now. Like I'm actually not sure this is a client issue. And I noticed that Maxim was moving his mouse plenty before it cut out. So I'm really not sure what the issue is, to be honest.
I don't think I can't imagine what can I do. So I will probably continue.
Yeah, Gideon is advising people that are having some issues to relog in basically here.
Sounds good.
Maybe we have a lot of users, and that's the part of the problem.
Yeah, can be. Just drop rejoin.
Okay, so before moving back to slides, one other thing to show in the console. I will remove the existing client-side data to show everything from the beginning, from inputting the schema from both of the implementations. So right now, if I check the contracts, which I have, or let's start with actually checking the interfaces, the schemata. I have no schemata at all. And the first time I'm running RGB command line tool, it will print out this information that it is creating a default stock and creating a wallet list. The wallet list will be an empty wallet list, and the default stock will be an empty default stock with only interfaces which are shipped with a standard library, which is RGB20. So there is no contracts, nothing in there. Now, also I can check interfaces. I see that I have this RGB20 interfaces. This is a built-in interface, which I showed in the first part of the demo. Now, what I can do is I can import the schema and the implementation I just developed. And I do import with the import command. It works with all types of RGB data. So no matter is it schema, contract, or interface implementation, imports does the proper distinctions and do the things that is required. So they are in the examples directory right now. RGB20 demo, I will start with a schema. So the schema is there, it's imported into the stash, it's printed out the ID of the schema. So if I do this RGB schemata command, I will see this schema. And that's it. Now I'm doing import of the interface implementation. So this schema now will implement RGB20 interface. And if I do it, I see that implementation of interface for schema is imported to the stash. And if I will do this RGB schemata once again, I will see that it sees the RGB20 interface over the schema now. But still, I don't have any contract. There is nothing in there. And the only way how I can get a contract, I need to import it from an issuer, or if I'm an issuer, I can issue the contract. So I'll do that right now. And to issue the contract, I need to provide a thing which is called the contract text, actually. So I will start with showing what the contract text is. The contract text is a YAML file that provides the information for the genesis. It also specifies which interface is used for issuing the contract, because issuing contract also requires an interface specification. And this contract creates a certain amount of assets, assigning it to an output which I control in my wallet. So I put it in there. I also specify the amount of assets and some information about the nominal. It is a test asset, and contract text, which just a usual thing saying that it's a shitcoin and don't use it. So that's how the contract is looking like. So it's pure, like anybody can write it. It doesn't require, you're not required to have a programming skill to do it. And now let's do the issuance. I need to check that I am using a proper schema name, which is not the case right now. So I will use this schema to issue this contract using interface RGB20 and this file. A new contract is issued and added to the stash. So if I will check RGB contracts, I will see this new contract. And I can also export this contract to an external file, this escape Lorenzo mouse contract. All contracts have this mnemonic, which is a basically mnemonical representation of the checksum of the contract itself. And if you try to change even a single character in this here, you will get completely different mnemonic. So it helps to visually see that you don't need to match this string that you haven't made a mistake in it, because if you had made, it will be detected using this checksum and mnemonic. So let me export this contract into a file, calling it contract RGB. It's actually wouldn't be fast. If I will skip the contract file, sorry. If I skip the contract name, it will print it to standard output. Here it is. This is the contract. Or I can provide a file name, and it will create a binary file, which you can see through the viewer here. It's a binary file of the same contract. Both can be used for distributing the contract to other users. So in this case, if I go to a different screen, and here I will be using a different directory for keeping the stash, I will see that I don't have any contracts. I don't have any schemata. Knowing for me, I don't have any well, I have just one interface, which should be a RGB20, which is built in. Now I can import this contract. So RGB D import test RGB, and the contract is imported. Now I can see this contract, and I see that together with the contract, I have received a schema and interface implementation. So these things are bundled together. When you share the contract as an issuer, you provide the users with all information they require to work with this contract inside the contract consignment. So here we see how we issue the contract and distribute them. So let's back to the slides and go to see what's next. Yeah, that's what we just did. There is an issuer guy that uses the schema to issue a contract, and there are contract users which can import these contracts, and these contracts will contain all this information on left side of the contract. It will be embedded into the contract consignment. So the contract is, in fact, a schema plus interfaces plus interface implementations plus genesis that provide the initial state of the contract. That's what is included. We've already discussed these slides before. It explains the difference between all these parts, interfaces, schema, interface implementation, and genesis, and compares it to object-oriented programming terms and Ethereum terms. But I wouldn't pay more time for that. You will be able to check that in the previous presentation. Now, let's do the transfer of a certain contract state from one user to another. But before doing that, probably we need to understand how we can see the state of the contract, which assets I do own. So for that, I will go back to the demo once again. Here. So let's check the state of the contract. RGB contract. I don't remember the name of it anymore. Yeah. And I will do the state of this contract. This wouldn't work because it doesn't know which interface I would like to use. So I will be using RGB20. And here is the state of the contract. I have the nominal information, contract text, and this amount of assets which I just issued to my UTXO. But wait a moment, it says owner unknown. Why? Because RGB system doesn't know anything about the outputs I own. It knows no wallet information. So for fixing that, I need to create a wallet. That is done with a create command. Not here. Let me import. The RGB can operate multiple wallets, and each of them has its own descriptor, and they are distinguished by the name. So if I will do this command, I'll RGB create actually wallets. Probably provide a list of wallet, which is right now empty. So what I will do, I will be doing RGB create wallet, providing I will name this wallet default, and this wallet will be used by default in all commands. And I provide a test public key. Right now, RGB operates with a single sig taproot wallets. That would change in the future, so I will add support for other wallet descriptors to this command. But at this moment, taproot single sig is the thing we go by default. So I do create this wallet, and I have this the private key matching this public key on my local machine, so I will be able to sign the transactions. So the wallet is created, and it uses this descriptor, which, as you see, is not a taproot descriptor. It's a tapred descriptor, a different one. Why it's required? Because when we use RGB, we create a tapred commitments, and this tapred commitments tweaks taproot outputs. And this tweaking information is a part of descriptor because without knowing it, wallet wouldn't be able to see output as belonging to it. So that's why we have to include this information about the tweaks into the descriptor itself, and that's why we can't use just a taproot descriptor. We have to develop this new descriptor type. This also prevents from accidentally spending RGB containing outputs by wallets who are aware of RGB, because if the wallet doesn't know anything about RGB, it wouldn't be able to parse the tapred descriptor. Now it will check the list of wallet. We see that there is a wallet we just created. And if we will do the same comment again, the same state comment again, we still see the owner unknown, unless we specify that we would like to apply the default wallet. And voila, here we see that it detected the derivation information, so the specific UTXO, which these assets are under. So if we will run a different command, which is called RGB UTXOs, it will produce the information about outputs for the default wallet, which it knows, and this output specific of this transaction derived with this derivation index is matched with this owned asset. So now from the perspective of the wallet, which will be integrating RGB system will provide all necessary information to present the proper data in the user interface regarding the owned asset by certain descriptor. Okay, so here we linked the wallet to the RGB state. What's on the other end of the story? The different user, our Alice. If we will check the UTXO set, here there is no default wallet on the Alice side, and we wouldn't register it for now because Alice would be accepting transaction, not doing transactions. And also, if we check the state of the contract we just imported here, it will show us that same state because the contract state is a part of Genesis. But here the owner is unknown because owner is the Bob from the other screen. So that's the setup we have before doing the transfer. Now back to the slides. There is some whiteboard present. I don't know what is it.
I already kicked it out.
Okay. So now we have Bob. The Bob has descriptor and seed. Bob has also created stash. He issued the contract. He sent this contract to Alice, and Alice also knows about this contract. That's the setup we achieved. As I said, the contracts can be exchanged by any means, including email, messengers, contract registry, which can be a website, or you can use even Lightning Network with a Storm protocol, as we was demonstrating a year ago. Now, we would like to do the payment. And the payment consists of 2 or 3 rounds. The first round is when the Bob will issue invoice to Alice, such that he can be paid from her. He will send this invoice via certain means. Then Alice will create 2 things. She will do a witness transaction in form of PSBT file, and based on this witness transaction, she will create a transfer consignment, which is an RGB client-side validated data, or simply transfer, which will be sent back to Bob. Bob will validate this consignment and create a signed payslip, sending it back to Alice. After what, Alice will be able to publish the witness transaction to blockchain, sign a published witness transaction to blockchain. So there is a certain interactivity required, but the good thing is that it is not required that both Alice and Bob should be online at the same time. So the same thing can work in a way that you can upload the invoice to a certain intermediary website, as well as you can do that with a transfer consignment. And the last thing, when Bob sends back to Alice a signed payslip, is also not required. So Alice can actually do the signing of PSBT and publishing it online at the same time as she sends the transfer consignment to Bob. The only risk is that Bob wouldn't validate the consignment due to some reasons, and Alice will lose her funds without being delivered with the good from Bob if she is buying something from Bob. And in that case, she needs to wait for a Bob payslip such that, and goods delivered by Bob, such that she is guaranteed that her state is not lost to her. So that's why I said it could be 2 or 3 stage process. There is also an UTXO secret, which Bob, who creates invoice, uses to hide his UTXO from Alice, while still allowing Alice to pay to him. I will be showing how this actually happens in practice in a moment. Going back to the So let's start with Bob, who creates the invoice. Invoice is created with an invoice command, surprisingly, and invoice command takes the name of the contract, and copy it from here. Invoice take command takes the name of the contract, interface to use for the invoice, amount of assets I'd like to receive, and the output I would like to receive these assets to. I also need to provide information which commitment scheme I will be using when I will be spending this output myself. So this output should be an output which I control, but nothing prevents you from using any output. You will just not receive the assets and you wouldn't be able to spend them. So right now I'm creating the invoice without a wallet registered, and I'm using some random output existing out there in the internet. And this is an invoice, which is an URL string starting with RGB, specifying the name of the contract I'm using, as well, you see it's MR, so on and so forth. So this is the name of the contract, the interface, amount of assets, and this is the concealed information about my UTXO I specified here. So it adds some certain secret, 64-bit secret to it, and it hashes it and provides the hash of this data as a part of the invoice, such that Alice receiving this invoice wouldn't ever know where the assets are going. I'm copying this invoice and sending it to Alice. And what Alice will be doing is that she will be doing a transfer operation based on that invoice. The transfer operation looks in the same way. RGB in the following way. Transfer. Let's see what arguments it takes. Actually, I can get more detailed information here. So I need to provide a PSBT file. So I have to prepare a PSBT file first. And this is the only task that RGB command line tool can't help me with, because RGB is not a Bitcoin wallet. I need to use a Bitcoin wallet controlling the same Bitcoin descriptor I imported into RGB to produce this PSBT file. And this PSBT file should spend the output on which I do have my assets. So if I will again check UTXO, I will see that I have this UTXO with this amount of Bitcoins. And on this UTXO with this amount of Bitcoin, and on this UTXO, I have a certain amount of assets under my contract escape Lorenzo mouse something. Yes, here, this is the output. And this is amount of assets I have there, and this is amount of test Bitcoins I have there. So now I need to create a PSBT spending this out. Fortunately, I have a tool called Descriptor Wallet, which is a command line wallet able to working with descriptor-based wallets and PSBT files. And this descriptor wallet already knows about the same wallet I'm using. I actually imported it into RGB from descriptor wallet. So if I will print the information about the wallet, this wallet is stored in the wallets RGB dev single SQL. I will see the same output, so it knows about this output I'm using in the RGB. And I will use this wallet to construct the PSBT file. This command I will be using. Here you are not restricted to a specific wallet. You can use any wallet that can construct a PSBT file. So right now I'm using Bitcoin descriptor wallet. I'm providing information about the input it will be spending, which is that output C9A86. You see it's here and here. So I will be spending this output. I will be using this wallet, which I just checked, and I will send the output, the result to transfer PSBT file. I will also pay 10 Satoshis for the fee, and I require to add a custom PSBT key specifying that the first change output can be modified with a taproot commitment. Without this thing, RGB wouldn't be able to see where to put the commitment and wouldn't be able to use PSBT as a witness transaction. So I do this construction. I'm getting this PSBT. It's also have been saved to this file in a binary form, and I'm checking that it uses the same descriptor I'm using for my wallet in RGB. Yes, this is the same descriptor, with the difference that here it is a taproot descriptor, and the descriptor wallet doesn't know anything about taproot at all and RGB at all. So, can I use the RGB, this new PSBT to do the transfer? I should be able to. So I'm doing the command RGB transfer, providing this PSBT file. Sorry, not this one, PSBT. Then providing invoice I just generated, I received from Bob. And specifying where to save the transfer consignment. In this case, I will use transfer RGB. This should prepare the consignment, and this also should do a lot of different stuff with the PSBT file, ending up with embedding taproot commitment to the transfer I'm doing. So what happened? Transfer is created and saved into transfer RGB, the transfer consignment. PSBT file is updated with all required commitments and ready to be signed, and the stash data are updated. What it means? It means that first, I can send transfer RGBT as transfer consignment to Bob. This transfer would not happen until I sign this PSBT file and publish it to the network. However, before I do that, Bob will be able to check the validity of the consignment and confirm to me that I can process with the payment. So let's do that step by step. First, let's look into what transfer RGB file is. If we will go into the binary viewer, into the examples directory, we see this transfer RGBT. It's quite a large binary file, which contains all the contract information plus the new operation I just performed. As I said, we have this nice RGB inspect command, so I can look into this file if I'm interested in. And it's not able to do that. Okay, anyway. I will trust that the file contains everything required, send it over to Bob, and the Bob here will do the following. It will do validate command. And the parameter that validate command takes is this transfer consignment as an input. So what we have here, consignment has a non-mine terminals. That's true. The terminal is the final operation, which was performed by the sender, which is the operation that Alice hasn't yet signed and published yet. So it specifies that this transaction, which mentioned in the consignment, and which is the transaction stored in PSBT, is not yet mined. And that's what we actually have to do at the Alice side once the Bob confirms that he's happy with the transfer. And Bob is happy with the transfer because at this stage, he sees that the rest of consignment is valid. The only thing that is missing is the final transaction. So he can send a confirmation to Alice, and Alice can do the actual signature. But before that happens, since Bob wants to avoid additional interactive step, he can already accept this consignment into his stash. And that is done with the command accept. Haha. terminal is unmined. It doesn't want to accept that because it's a precaution measure. What we need to do is specify a force argument which will allow us to accept consignment, which is valid except the terminals into the stack. So now transfer is accepted into the stack. And if we will check the state of the contract, I don't remember the name of the contract, though. It is RGB 20. I will see that now 100 of assets from the invoice paid are allocated to a new transaction, which is an output I had provided to Alice in my invoice. If I will go up, oh, sorry, I haven't saved the invoice I created, but this is the same output I put into the invoice, which was hidden with the secret and behind the hash. And now RGB was able to resolve this information back and match the incoming payment with the secret it has created as a part of the invoicing process. So before it was done, for instance, on the wallet side in the previous RGB version, creating a lot of integration problems to keep all this track of this data. Now it's all embedded into the RGB libraries. Another thing which appears here is the witness. This is transaction that confirms the operation transferring this amount. And this transaction is right now is not mined yet. So if we will go into a blockchain explorer, we will see that there is no mined transaction. And that's what means that the consignment has a non-mined terminals. But Bob can now wait for the mining of the transaction to happen in the off-chain mode because he owns the stash and he has all the data in the stash and he does not need to receive anything from Alice anymore. Meanwhile, what Alice does is she signs with the BTC hot wallet the PSBT file. And she needs to provide the private key. Oh, sorry. And publish to testnet. No, not publish yet. Sign. There is no account password, so we did the signature. The transaction is signed, and now we can publish it. Publishing to testnet. If we will, before we're doing that, if we will pay attention for a moment what this PSBT file is. After we did the RGB operation with this PSBT file has been significantly modified. If we use BTC called wallet to inspect this PSBT transfer, we will see that there is a number. So this is the PSBT. We see the inputs we are spending. There is just one input, and there is nothing interesting happening there other than there is a key specifying RGB specific information on this input. And there is outputs. With the index 1, we see that it inserted the top red commitment into the top tree, which was absent from here before. If I regenerate the same PSBT, here I will use just a different name, calling it original. You will see that initially the output was just a plain taproot output, not having just a keep us spending, no tree at all. And now this output got a tree which contains this taproot commit. And that's why the descriptor for this wallet is taproot descriptor, because no other descriptor will be able to see this tweaked output. And we see plenty of new proprietary keys added, which are part of the taproot commitment process, as well as a proprietary key on the top level of the PSBT file. But still, as you see, we were able to sign this PSBT file. And if I will change to, for instance, Sparrow wallet. One second, we start in testnet. So if I will go into the Sparrow wallet here, I see I have the same wallet open here. If I will load the transaction, this RGB transfer please BD. I see that the Sparrow wallet is able to read this transaction and is even able to broadcast it. So I can do it from command line or from Sparrow. Let's do it from Sparrow. Yes, it has been broadcasted. So the transaction has happened. We see it as unconfirmed. And this is the witness transaction which finalizes the transfer Alice did to Bob. So that's it. Now Bob will see. Yeah, go on.
Could you post that transaction ID in the chat?
Yeah, sure.
Fantastic. Really well done, by the way, Maxim.
Thank you. This is one. TBC 88.
Thank you very much.
Yeah. So, is my thing. So again, we already have seen that Alice see this state as an updated state. The wallet user interface on top of RGB will be able to filter out the state until this transaction is mined. So now when it's mined, the state becomes valid and the actual state of the smart contract. That's it. So that's the way the transfer has happened, and that's the way Alice has finalized it. I'm glad that we were able to fit into around 1 hour. And I think we can move to discussion and questions.
That's absolutely amazing. Thank you, Maxim.
Thank
I
you.
was kind of surprised that you were showing everything on the testnet, not on the mainnet, knowing how reckless you usually are. But thank you.
Well, I spent all my bitcoins on doing RGB, so I don't have any mainnet bitcoin to do the demo.
That's funny.
That's fair.
Well, it's true. It's not. But anyway,
it's painfully true. Okay. If anyone wants to donate to us testing RGB on mainnet, please, I will tweet a couple of links and QR codes. So if you're feeling generous for us to test mainnet RGB stuff, please share some sets. Thank you very much. Coming back to the presentation, there were two questions already. The first one is, Maxim, do you have plans to migrate the RGB descriptor to the descriptor wallet repo? And do you have plans to migrate the RGB invoice to the universal invoice repo?
Okay, so descriptor, well, it's a bit messy, I have to say. So the problem with the descriptor wallet repo is that it is based on miniscript, while the thing I did with RGB and I showed it with RGB is not based on miniscript. So they a bit incompatible. And it goes even deeper because of the difference of Rust Bitcoin versions and so on. So eventually, of course, this will be all descriptor wallet will be using taproot descriptors and everything will work smoothly. But it would happen only when Rust miniscript will be released with the new Bitcoin version, after which we need to do a PR to miniscript to accept the taproot descriptors, which they probably won't. So I think it would take months and months for this to happen. So for that reason, basically the only way how you can interact with the taproot descriptors is through the RGB library for now. because basically no existing descriptors support taproot commitments. Or you can use a normal non-taproot wallets and then do op-return commitments and don't have this pain. Regarding the invoices, the universal invoices was based on a different concept. So they were designed for the previous version of RGB. So I think we will release invoices as a separate library such that light clients can use it without using the whole of RGB. So I think this library is required, but it wouldn't be merged with universal invoices. So universal invoices will remain where they are. We will probably work on redesigning them, supporting lightning channels and everything based on this new invoice format, but it would happen later.
Great. Thank you. Hunter just dropped a message that he can't see the transaction you just did in the mempool.
Can't see? Okay.
Cannot see, yeah.
Because you need to use testnet?
He is checking testnet.
Let me check.
Yeah, I also do not see it.
Yes, interesting. Let me publish it once again from the Sparrow wallet, because Sparrow wallet have seen it and now it sees as an unconfirmed. So I think it was missed from the testnet. Interesting. Sparrow doesn't provide me ability to publish transaction again, so I will do it from the command line.
Can you maybe share your screen while you're doing this?
Just 1 second.
Mm-hmm.
Examples. Mainnet. We test that. The mean relay fee is not met. Okay. So I have to redo
that's not a fee rate. That's the actual fee itself.
Yeah, I put on the 10 satoshis as a fee, so it was less than the minimum relay fee. So that's why it went off the mempool. But don't worry, I can do it again. So I will do the construction of the transaction with a different fee, paying the same invoice. So what was the minimal fee? Like 200? Let's put 200.
Sure, it was 112 actually. But yeah, one thing I also want to mention, point out at least, is that it's funny how Sparrow never told you this, whereas your own wallet did. So in a way, you built a better wallet than Sparrow.
well, they're not yet better, but it has potential at least. So I'm doing this transfer.
Maxim, you're too humble. You were supposed to react something like, yeah, fuck yeah, stuff like that.
No, I will not do that. I will do the signature. Then one signature, publish. Yeah, now it's published, but the transaction ID is different because I changed the fee. But no worries, I have the new consignment, transfer consignment, which I can now validate. This is the new one. And now we see the consignment is valid because the transaction is mined. And it's some warning that there is duplicated terminal seal, but it's not a problem. And now I can accept it. I I don't need to force because now it's the lightness transaction is also mine. And I can probably see the state of the contract. I never tried that. Hopefully it will work properly. So, state of this contract. Yes, I see this new transaction. And as you see, the old state is not have been removed, which is fine, and that is the intended thing. So if there will be a rework happening, and the new transaction will be removed from the blocks, and the older one will be added, I will still have the valid stash because I cover both of these cases. And it is the matter of the user interface to filter the state which is related to the witnesses which are not mined or mined at a small depth. That's why this witness information is provided. And as we see, this original transaction which never get to blockchain will be filtered out, while this new state from this new transaction, new transfer, will be present on blockchain, and that's why the wallet may show it. So getting back to the testnet, yes, this transaction is mine. So and here we are.
And now you're overpaying 80% for the fee.
Yes.
Amazing. Can you please put the transaction to the chat so that everyone could check it too? Thank you. Sorry.
No, it went through this scenario I never tested, whether it's a different transaction paying the same invoice.
Well, it's a good thing that now we tested it and now we know that it does work. So, still cool. Okay, guys, any other questions?
I have a question regarding the transfer command. So yeah, in the example you pasted an invoice. You provided an invoice that had the asset ID and the amount already specified. So I was wondering, in the case the sender wants to decide, for example, the amount, is there like an option to add it, or you should tweak the invoice to do it?
I'm not sure. Probably in command line tool there is no option to do that, but the invoice library itself, it's already have. Zoe, she actually proposed the change which I accepted before the release. So invoice library allows to do that. So you will, when you do that from the wallet, from inside the wallet through the API, you will be able to generate that kind of invoice. But it's not part of the command line probably, just because I forgot about that and haven't time to do that. Yes, the value is required for now, but I will do that.
But
later.
If let's say like I want to pay an invoice that doesn't have the amount, could I just add the amount, like change the invoice, adding the amount?
Yes.
Before?
Yes, and it will work. Yes.
Okay, great. Thank you.
Anything else? Okay, then. The fact that you were able to replace your transaction that fast says a lot about the big UX improvement. Very nice work.
Thank you.
Great.
Yeah, it's funny. Like you essentially went off the happy path. So like in a way, it was almost like a bit of QA in that original mistake you did. And what's remarkable is like, I don't know if you had already tested for that scenario, but it's kind of unusual for, a program to work, right? To handle an error and during a demo, no less. Yes.
I never tested
gracefully like that. That's really cool. That's really cool. This is special, man. The ODA 10 release is just so special because it represents the sort of culmination of all this effort that you put together over effort and money and time and energy over the past 2 to 3 years now, over 3 years actually, probably by your count. And it is just so cool to have seen this project come from, where it was I kind of started seeing it in 0.4, when it was just a tokens protocol. And now it has really flourished into this very well-refined, well-executed, generalized smart contracting framework. And that's just so special, dude. Mad respect. Congrats.
Thank you very much. It's very important for me to hear. And I also have to say that it was impossible to come to this user experience without all these intermediate steps and feedback I got from new developers and people who were trying to integrate, because yes, previous versions of RGB were very painful to integrate. And that was because of this strong paradigm change into the client-side validation. It was really hard to understand how to build all these workflows where you have the client-side data, transactions plus the state transitions outside. And without multiple iterations going through the integrations that you've done, I wasn't able to understand how to properly build the API. And finally, it seems that we're reaching the stage where it is consistent and integratable by normies.
Yeah, I still remember the time when we tried, like Maxim, you tried to build an RGB wallet, and then it turned out all of a sudden that in order to build an RGB wallet, you first need to build a Bitcoin wallet, and none of the existing wallets at that point had any functionality that we needed. This is why the descriptor wallet library even appeared. So yeah, it's been a long path. Great job.
Yeah, thank you.
There is a newbie question. Bravo for your work, first thing.
Thank you.
And the question is, do you need to publish a transaction on chain each time you transfer? If not, when do you need to publish on chain?
You need to publish transaction each time on chain during the transfer if you're doing on-chain transfer. If you're adding assets to Lightning Network, to a channel, Lightning channel, you don't need to publish a transaction on chain. You need to update the commitment transaction inside the Lightning channel each time you update the RGB contract state. So you still each time update the transaction, but depending where transaction do exist in the blockchain or in the channel, you update the transaction in the blockchain or in the channel.
Okay, understood. Great.
Yeah, maybe next time we can have a look, have a call about Lightning and the state of the work on this front.
Yeah, that would be very cool.
Indeed.
I would also like to maybe at some point give a demo of Bitmask once we've integrated 0.6.
I will be happy to shift to you guys, so you will be doing demos and talks with me finally.
Yeah, that's going to be really cool.
I have a post-traumatic stress disorder regarding our weekly calls. Oh, this week I need to prepare another demo.
Yeah, I mean, honestly, like I've seen some pull requests come through like hours before the call. I can only imagine your stress level for the time we all coordinate. And you always seem to manage to get that out last minute. It's really cool.
I found that my productivity is at the top when I have a very tight time restriction. Like in half an hour, everything should work.
That's true. Yeah, I totally get that. Yeah.
But you'd better not abuse that, because your stress hormones will not do you good in the long run. So sometimes it's better to receive all the feedback on timely manner instead of like pushing everything to the last minute and then demonstration not working and go through all that stuff.
Well said, Olga. As a neurobiology major, I think that you'd be the most qualified to make that that statement.
Thank you very much. Okay, guys. So I would say last call for questions. Okay, great. Then I think we can wrap this up. Maxim, thank you very much for the demonstration, the slides, and everything. It's probably been like one of the best calls that we have ever had over the past 3-4 years. It's been. Amazing job. And guys, thank you very much for your feedback throughout all this time, and especially today, and for the last minute PRs as well. I will post the video of the call and all the recordings online as usual. If you have any questions, you know where to reach out. Use Twitter or Telegram. Those are usually the best choices. Or GitHub. GitHub is the place where Maxim's usual habitat. So if you want him, go there. Thank you very much, everyone. Have a good day. See you next time.